So this is what the stack looks like if you stepped through function plus 6. And it's worth noting here that if this is main's frame, this is function's frame, z is still uninitialized. So this area was sort of notionally reserved for z, but at this point in the code execution, we don't see anything filled in there because the z is set when you return from func. So it's allocated but uninitialized. However, when you get down into here, you do see that for whatever reason, func decides to store its argument to the function on the stack. It stores it out, and then it immediately loads it again, being, again, one of those sort of pointless things that seems to happen from unoptimized assembly. But this is what you see when you're inside of func, and then I'll just point out that if you return back out of func, this stuff becomes undefined because it's now lower than the stack pointer. It's passed to the stack top, and at that point, the truncated version of faceless cold cola is going to be placed into Z. Z is going to be at the upper 4 bytes, as we've seen throughout that when there's a single int, it gets the upper 4 bytes of a 8-byte allocation. But let's go ahead and look at this code a little more carefully, just to highlight some things. We saw that the constant faceless cold cola was loaded into the argument 5 using the WePC plus add. WePC plus 0 means you just get PC into A5. A5 plus a constant means you get some hard-coded address where presumably this 64-bit value is stored right after our code somewhere, and then loaded into A5, and then A5 next is going to be A5 into A0. And so this is the key thing, that A0 is the argument 0. It's the 0th argument to the function func. So anytime you see things setting up A0, A1, A2 right before a call or a JAL to a function, then that means they're setting it up to be used as an argument to that function. Then when we JAL into the function, we have, typical frame pointer setup, typical function prologue, but then there's that seemingly pointless storage of A0, which is the argument, store it out to memory, but then immediately pull it back in from memory. And then there's this extra sign extension. But because this is a sign extension word, that means this 64-bit value, which is faceless cold cola, is going to be truncated down to a word size, a 32-bit value, just cold cola, and then sign extended into A5. So all of a sudden we just lost the upper 32 bits, they become just Fs, and so now it's just going to be this integer type value. And then after that, we see that integer-sized value being stored into A0. So that is the return value. So as we're returning out of a function, placement into A0 or A1 should be construed to be the code loading something into a return register. And then when you return back to main, you're going to see the sequence, the use of the A0, which is the return value. It's moved into A5, but then it's stored out to memory, and then it's pulled back into memory. Well, the store out to memory, that is going to be the storage to the Z variable, and the loading it back into the exact same register it's already in. That's just typical unoptimized code. And then storing that A5 into A0 is further making it a return value for returning back out of main. So basically in this code, we saw the use of A0 as an argument register going into a function, and we saw the use of A0 as the return value coming back out. We saw some unoptimized code doing, the typical unoptimized, unnecessary things. But yes, this is the basics of calling into a function. It's the placement of arguments into the A0, A1, A2, but we only saw A0 here because we're calling a function with one arg.